Now, in previous lecture, we took the relation between wave velocity and velocity of a particle. So that was that was u, or dy by dt was equal to minus v dy by dx, where this is velocity of particle, this is velocity of wave, this is slope of wave at an instant of time. Now again, remember that the velocity, this equation of velocity of particle was y was equal to dy by dt, that was equal to 2 pi by lambda a v cos 2 pi by lambda vt minus x. Okay, now if we differentiate this again, so what we will get is du by dt, which will be equal to d square y by dt square. This is what? This is nothing but acceleration. Okay, so if we double differentiate y, then the equation that we will get in the end will be equal to minus 2 pi by lambda a, sorry, not a, it remains outside, v square into a sine 2 pi by lambda vt minus x. Differentiation of cos is minus sine, okay, and the rest goes like we have done before. Okay, so acceleration is basically equal to minus 2 pi by lambda v whole square a sine 2 pi by lambda vt minus x. Now this is equal to y, na? Y was equal to a sine, y was in my initial equation, a sine 2 pi by lambda vt minus x. So we can rewrite this equation as acceleration a is equal to acceleration, since we are differentiating velocity, okay, velocity of particle. So this will be acceleration of particle will be equal to minus 2 pi by, instead of lambda we are writing like this, I am writing v upon lambda whole square, okay, y. Now v upon lambda is equal to minus 2 pi by time period whole square y, since v is equal to lambda by t. Okay, so we can rewrite this part as acceleration of particle a, acceleration of particle, okay, a is equal to minus omega square y. Now you have seen this equation before in SHM. This means if this equation is coming out, it means that the particle is executing SHM about its mean position. Now remember, in first lecture itself I told that the in the characteristics of transverse wave, in which I wrote that in transverse wave the wave travels in forward in positive x direction, whereas the particles execute SHM in a direction perpendicular to it. Okay, so this is the derivation of that point, and by doing this derivation I am sure that since the acceleration of particle turns out to be equal to minus omega square y, which was also the equation for acceleration for a particle executing SHM, so basically the particle of medium is executing SHM under the acceleration, this is equal to minus omega square y. So we can say that the acceleration is maximum, acceleration of particle is maximum at extreme position, which will be at extreme position, which will be at the position of amplitude for a wave. Okay, and acceleration of particle is minimum at equilibrium position, because y is equal to 0 at that point, but at this point velocity will be maximum. Okay, you can understand that through SHM. Okay, now I'll be looking into reflection of a wave. Okay, this is a very important topic. I hope that you understand well, and if you have any problem then feel free to ask. Okay, so reflection of wave. Reflection of wave. So reflection of wave can happen in two ends, can happen in two ways. That reflection is taking place, reflection is taking place at rigid end, and there is one more way, that reflection is taking place at flexible end or at free end. Now I will describe both of these individually, but for transverse wave. For longitudinal waves I will explain it when I will be taking the topic of closed and open organ pipes, but for now I will explain this with respect to transverse wave. Okay, so first point, reflection at rigid end. Okay, so suppose that there is a string and that string is attached to wall, and in this string there is a wave pulse which is moving. Okay, so imagine how this wave pulse will be moving. Suppose my hand is that string and this part is attached to wall, so a wave pulse will be moving like this. It will move like this. Okay, it will move like this part, and then it will go forward. Okay, so as the wave pulse travels forward, it gets closer and closer to the wall until it actually reaches that wall. At this point it actually reaches the wall. So now as it reaches the wall, here at this point the string or the particles in the string will have a tendency to exert a force acting upwards on wall. Okay, because at this point the wave is like this and it needs to displace the wall. Now like this, the wave is coming like this, the wave is coming like this, and this part is attached to wall. The wave is coming like this and this part is attached to wall. So see, it will have a tendency to, it will exert a force on the wall acting upwards. So if this is your action force, then the wall will exert a force downwards on this wall, on this string. This will be your reaction force. So as an effect of this reaction force, what will happen, that a pulse will generate in opposite direction of same amplitude. The amplitude increased in this case, but it won't be unequal, but it will be of equal amplitude. Okay, so so as a result of this reaction force, a wave pulse is generated in opposite direction and the wave pulse travels like this in opposite direction. So initially the wave pulse was traveling in this direction. After interacting with this wall, the wave pulse started to travel in opposite direction. So what we witnessed here was a reflection at rigid end. Rigid end means that this end was not free to move. Okay, this end was not free to move. Okay, so reflection at rigid end. So in this case, what we witnessed is that reflected wave is 180-degree opposite of incident wave. See, this was your incident wave. This was your incident wave. Whereas this is your reflected wave. And if you see a sine curve, this is 0, this is 180, and this is 360. Okay, so we can see that if this part belongs to this incident wave, then this part is your reflected wave, and there is a clearly angular difference of 180-degree. So reflected wave is 180-degree opposite of incident wave. Or it can also be said that the reflected wave is a opposite phase that of incident wave. Okay, 180-degree opposite, or pi radians. Now let's take the next topic. The reflection is now taking place in free end. Reflection at free end. Second part. Now suppose in this case the string was attached to rigid wall, but in this case the string is attached actually to a rod basically, and there is a ring attached to it, and this so basically the string is attached to this ring, and this ring is free to slide up and down of this rod. Okay, now there is a wave pulse approaching. So as the wave pulse approaches with time, now in this case, now we see that the wave pulse actually approached here. So again, this wave pulse will have a tendency to go up, and the ring will slide happily because there is no resistance. We are assuming that there is no friction between them, so there is no resistance. So this ring will slide on this rod as the wave pulse exerts an upward force on this ring. So slide, when it keeps on sliding, what will happen? Like this is your that rod, this is my rod, and this is your, in this case here is the ring. So the wave came like this. Okay, wave came like this, wave came and it came like this, and now it is sliding up and then it will slide down. Okay, so the wave came like this. Okay, so the ring will slide up and then it will slide down. So now the ring is sliding up. Now it is at the position of the maximum amplitude of this wave pulse. Maximum amplitude, it is at that distance. Now the ring will tend to come down. So as the ring comes down, now the ring is coming down. Okay, along with that the string will also come down. Now the ring is coming down, ring is coming down further. Now the ring has reached its equilibrium position, and we can see that there is a wave pulse created again. So after some time this wave pulse will travel forward in this direction. So we can see that this was the direction of incident wave pulse, whereas this is the direction of reflected wave pulse. So clearly reflection took place. Reflection took place at free end, which basically didn't supply any sort of hindrance to the incoming wave pulse, whereas at reflection at rigid end, this end basically provided an obstacle, provided an hindrance to the incoming incident wave pulse. Okay, so reflection took place at free end, and we can say that reflected wave is similar to incident wave. Okay, reflected wave is similar to incident wave. If you see, then this is, if this is your incident wave, okay, and you can see this is your reflected wave. Okay, so there is practically no distinction between them apart from their direction in which they are traveling. So if we ignore that, then as long as we are considering the physical characteristics, there is no difference between incident and reflected wave. This wave is traveling in this direction and this reflected wave is traveling in this direction. So we are not considering direction, but the physical characteristics or the equation of for the incident and reflected wave. Okay, not equation, sorry, the physical, the graphical nature. Okay, these two look exactly the same. So reflected wave is actually similar to the incident wave, or we can rewrite this in angular or in phase form, that reflected wave is 0 degree with incident wave, 0 degree or 0 radian, or 0 radian, or we can also say that reflected wave suffers no phase reversal. Reflected wave suffers no phase reversal when reflected through free end. Okay, this is very important point. Reflected wave does not show no phase reversal, okay, while reflecting through free end, but for rigid end, reflected wave suffers pi radians phase reversal when reflected through rigid end. So there is a phase reversal of pi radian when reflected through rigid end. Okay, always remember this point, that in while reflection from free end, while reflection from free end there is no phase reversal. While reflection from free end there is no phase reversal, but while reflection from rigid end there is a phase reversal. You can see the incident and the reflected waves. Okay, so while reflecting through rigid end there is a phase reversal of pi radians, and while reflection from free end there is no phase reversal from free end when reflection took from free end. Okay, now in next lecture we will be continuing this idea itself. Okay.